Welcome back, late-night travelers, to tonight's journey. Before we begin, try leaving a small comment. Where are you listening from, and what time is it, where you are, right now? Wherever you may be, let this voice carry you away from the present and back to an ancient Earth. A world with no traffic, no city lights, no human voices, only wind, stone rivers, forests, and living creatures, struggling to survive in a world that changed day by day. Tonight we will travel back more than 230 million years to the late Triassic period, when Earth entered one of the strangest climate episodes in the history of life. People often describe it with a powerful image, the age when Earth reigned for 2 million years. It was not rain falling continuously every second, but a long, humid age when the sky grew heavier with water. Rivers began to rise dry and heated ground turned into mud, and new forests slowly spread across lands that had once been barren. In that world, survival was no longer simply about running faster, biting harder, or having a larger body. Survival meant adaptation. It meant finding food when the plants had changed. It meant reproducing when nesting places were flooded. It meant passing through long, rainy seasons, muddy rivers, dark, wet forests, and the empty spaces left behind by older species. So, how did animals survive when Earth sank into that long age of rain? And why, after that great rain, did dinosaurs begin to step onto the stage of history? Lie down, relax, and let us enter the story together. Before the sky grew heavy with water, before the rivers began to rise, before the cracked, dry ground of ancient Earth turned into mud and humid forests, the world had once worn a very different face. It was an Earth so distant that no human voice had ever echoed beneath its sky. There were no green grasslands stretching wide as they do today. No flowers opening in the wind. No birds resting on branches in the early morning. There was only a vast planet, hot and dry, slowly recovering from the deepest wound life had ever endured. Imagine yourself standing on the ground more than 230 million years ago, near the end of the Triassic period. The air feels heavier, dustier, and unfamiliar. Before you is not the familiar map of the world, with oceans dividing the continents into separate pieces. At that time, nearly all the land on Earth was gathered into one enormous supercontinent called Pangaea. It stretched like an immense body of land, so vast that if you stood deep in its interior, the ocean might have been only a distant idea lying beyond every horizon. Pangaea was not a gentle land. When most of the continents were joined together, regions far from the sea became drier, hotter, and subject to harsher seasons. By day, sunlight could bake the red ground into a hard crust, cracked like dry skin. Wind swept across open spaces, lifting dust into thin, drifting veils. The rivers were not always full of water. In some places, flow appeared only with the seasons, leaving behind stony riverbeds and dry mud when the water withdrew. Elsewhere, lakes lay still beneath the sun, shrinking month by month until their shorelines retreated and left behind old rings of hardened mud. If we walked slowly through that land, perhaps the first sound we would hear would not be the sound of a dense forest, but the sound of wind. Wind moving through sparse conifer canopies, through low cycads, through ancient trunks, unlike any modern forest. Plants were present here, but the green world was not yet as rich as it would later become. There was no soft grass beneath the feet, no wildflowers along the path. The vegetation was made mostly of ancient forms, conifers, ferns, ginkgos, cycads, and species adapted to a hotter, drier world. They did not create the soft forests of our imagination, but scattered patches of green resilient, sometimes low, sometimes thin, clinging to the land as though enduring more than blooming. But this earth was not empty. Life had returned, though it still carried the marks of a very distant catastrophe. Before this time, at the end of the Permian period, the planet had passed through the greatest mass extinction in the history of life. Most marine organisms and many forms of life on land had disappeared. The Triassic period was the world after that loss, a world rebuilding itself from what had survived. So when we look at the landscape before us, we should not see it as a peaceful stage, simply waiting for the rain to arrive. We should see it as a body that had just recovered from a grave illness, standing again, breathing again, but not yet fully stable. Across that dry ground, animals unlike those of today began to move. Some had low, sturdy bodies, strong snouts, and teeth suited for grinding tough plants. Others walked in strange ways, not quite like lizards, not quite like mammals, as if they were ancient sketches of life before nature chose the more familiar shapes we know. There were plant-eating reptiles that had once been very common living across broad regions and feeding on ancient plants growing from dry soil. There were also mammal-like reptiles left over from earlier times, living witnesses of a Permian world that had collapsed. They did not know they were remnants of the past. They only knew how to wake search for food, avoid predators, reproduce, and continue through the long, dry seasons. Among those creatures, rhynchosaurs were one of the memorable images of the world before the rain. They were not dinosaurs, nor were they mammals, but a group of plant-eating reptiles that had been highly successful in many Triassic ecosystems. Imagine an animal with a low body, sturdy legs, and a distinctive snout bending among dry clumps of vegetation, using powerful jaws to process hard and fibrous food. It did not need a majestic appearance to become an important part of this world. It lived through suitability. Its body matched the plants it ate, the land it crossed, and the dry seasons it endured. For a long time, that was enough. Elsewhere, Decinodonts were still present. They belonged to a very ancient branch of life, closer to the line that would lead to mammals than to modern reptiles. Yet their shape makes us feel as if we are looking at one of Earth's early experiments. Some species had large, heavy bodies, beak-like mouths, and sometimes tusks projecting outward. They had survived earlier upheavals, had passed through the collapse of the Permian world, and still continued to exist in the Triassic. We can imagine them as slow-moving shadows on ancient plains, neither hurried nor graceful, but enduring. Each step they took on dusty ground was a sign that the past had not completely left the earth. Yet this world also had predators. During the Triassic, the archosaurs were becoming increasingly important. This was a large group that would later include both the crocodile line and the dinosaur line. But at this point, the story did not yet belong to dinosaurs alone. Many non-dinosaur archosaurs were the more dominant animals on land. They may have been long-bodied predators with powerful snouts and sharp teeth walking along dry riverbanks or lying in wait near places where prey often came to find water. In the dry sunlight and red dust, silence was never truly safe. A movement between the trunks, the soft roll of a pebble, a low shadow passing along the water's edge, any of these could be the sign of death drawing near. The first dinosaurs had already appeared in this setting, but they were not yet the giant kings we often imagine later. They were still relatively small, still modest, and in many places only a small part of a much wider ecosystem. If a person could have stood there and looked across the Triassic plain, perhaps they would not have noticed them immediately. Perhaps there would only be a lighter, faster creature, walking on two legs across open ground, then disappearing behind low shrubs. It did not make the earth tremble. It did not block out the sun. It simply passed by like a small whisper of the future. What makes this moment so special is the fragile balance between old and new. Ancient groups of animals still held important roles. Plant eaters adapted to dry ecosystems were still abundant. Predators that were not dinosaurs still occupied terrifying positions in the food chain. The plants were still the plants of an earth without flowers, without grass, without modern forests. Everything seemed to have its own order. But that order was not permanent. It was only a temporary slice in the long history of life, a quiet pause before the climate began to turn. Let us move deeper into the interior of Pangaea. The farther we go from the sea, the clearer the dryness becomes. The ground may shift from sparse vegetation to dusty plains, then to open stretches of land where sunlight falls without anything to stop it. During the dry season, water becomes the center of every movement. Animals remember the way to shrinking lakes, to rivers that still hold a little water, to low places where mud keeps a trace of moisture beneath the surface. Every evening, footprints overlap around the water's edge. Small footprints, large footprints, clawed tracks, hoof-like impressions. A lakeshore like this could be where life gathered, but it could also be the most dangerous place because predators knew that prey would have to come. A long day in that world may begin with pale light over cold ground. At night, the temperature may drop, leaving a still dry layer of air over the plain. When the sun rises, heat slowly begins to lift from the earth. Small creatures leave their shelters. Plant eaters begin moving slowly toward areas where vegetation remains. Predators lie still, saving energy, waiting for a better moment. There are no birdsong sounds, but that does not mean the world is completely silent. There is the sound of feet over gravel, the sound of dry leaves rubbing together, the heavy breath of an animal near the lake's edge, the very faint sound of water moving through a cracked channel in the earth, so precious that every living thing nearby is drawn toward it. In that hot, dry world, survival was a problem repeated through every season. Which species could eat what? Which could endure a lack of water? Which could move far when old habitats dried out? Which could reproduce at the right time so their young would not die when food was scarcest? These questions were not asked in language, but answered through body's behavior and the success or failure of each generation. An animal surviving one dry season was only a lucky individual. But a species enduring through thousands, through millions of years, needed a deeper fit with the environment around it. That is why the world before the rain should not be seen as weak. It was harsh, but it had produced animals strong enough to live within that harshness. Rhynchosaurs, Dicynodonts, predatory archosaurs, and smaller creatures hiding in rock crevices or beneath tree roots, all of them were the result of a long period of adaptation. They did not know they were living before a major upheaval. To them, each day was simply another day beneath the Triassic sun. Each dry season was a familiar trial. Each brief rain, if it came, was only a temporary relief before disappearing back into the earth. But that very familiarity made the world fragile. When an ecosystem has adapted for too long to one kind of climate, it may be very strong under familiar conditions, but vulnerable when those conditions change. A plant-eating species can be highly successful as long as the plants it needs remain. A predator can dominate as long as its prey continues to follow old routes. A nesting place can be safe as long as the water comes and goes according to the old rhythm. But if that rhythm changes, if wet seasons begin to last longer, if rivers and lakes no longer behave as before, If plant communities begin to shift into something different, then old strength may no longer be strength. At this moment, we have not yet entered the age of rain. The sky still keeps its dry and open appearance. Clouds, if they appear, pass like thin shadows across the red land. But in the rock layers that scientists would read much later, this world was already close to a great turning point. Landscapes that seemed solid dry plains, seasonal rivers, sparse forests, familiar plant-eating animals, predators holding high positions. All of them existed in a moment before the climate began to shift. There was no warning bell, no creature lifted its head and understood that history was about to change direction. There was only the ground, the wind, the sun, and a planet quietly gathering the conditions for a new chapter. Seen from very far away, Pangaea, at that time, was like a colossal body lying beneath the sun. The ocean surrounded it, but could not soften every region within. Mountain ranges, valleys, plains, riverbeds, and basins rested in the reddish-brown colors of stone and dust. Life clung to its surface in patches along lines of water, in zones where plants could survive the dry climate. Nothing was truly dead, but the world was not yet as rich as the worlds that would come later. This was Earth, in a period of waiting, though it did not know what it was waiting for. And perhaps if we stood beside a drying lake at the end of a Triassic day, we would feel most clearly the silence before change. The sun sinks lower, spreading light across cracked, dry mud. A group of plant-eating reptiles leaves the water's edge, leaving deep footprints in the softened ground. Farther away, a predator lies motionless in the shade of sparse trees, its eyes following the last movements of the day. Small animals slip into shelter. The wind grows gentler. The sky darkens wide and unfamiliar, covering a world that does not know that in the near future of geological time, water will become the main character. Before the 2-million-year reign, Earth was like this hot, dry, vast, ancient, filled with strange creatures living within a temporary order. It was the world of those who had survived the previous catastrophe, but did not yet know they were about to be tested again. It was a stage where older lineages still held the center, while the first dinosaurs remained quietly at the edge of the story. And within that silence, a silence that seemed completely ordinary, the history of life was standing before a very great door. But that change did not begin with rain. It began deeper, farther away, in the place where the planet's molten rock found a path upward to the surface. In Earth's history, there have been moments when volcanoes were not simply lone mountains sending smoke into the horizon. There have been moments when an entire vast region of Earth's crust was torn open, allowing lava from below to surge upward in repeated waves over stretches of time so long that even if someone had stood there watching, they could never have seen the beginning and the end within the brief span of a single life. Imagine us leaving the dry interior of Pangaea behind, traveling very far toward the edge of the ancient ocean. There, where land and sea did not yet resemble the map we know today, a gigantic volcanic region was active. Today, its traces are recognized in ancient volcanic rocks found in Alaska, British Columbia, and parts of northwestern North America. But more than 230 million years ago, it was not a place name on a map. It was a red-hot wound in the planet, a place where Earth opened itself and breathed with fire. This was the region associated with Pangaea, a large igneous province where eruptions may have poured enormous volumes of lava into the ancient ocean. That image was not like a short explosion from the mouth of a volcano. It was more like a prolonged process, many rhythms, many pulses. Lava spread across the surface, cooling into black stone. hot gases rose from fissures. Dust, sulfur vapor, carbon dioxide, and many other gases entered the atmosphere. Each eruption was like a violent breath from the depths of the earth, and after many such breaths, the sky began to carry a new burden. On an ordinary day in the modern world, we easily think of the atmosphere as something invisible, light, and distant. But in truth, the atmosphere is the thin cloak that decides the rhythm of life for the entire planet. If its composition changes, temperature, rain, wind, oceans, and forests can change with it. When volcanoes release more carbon dioxide, that gas traps heat in the atmosphere. Earth warms, the oceans warm, more water evaporates. And when warmer air can hold more water vapor, the sky begins to grow more humid, heavier, and ready to create longer and stronger rainy seasons. What matters is that we should not imagine it too simply, as if one volcano erupted and rain immediately fell across the entire Earth. Climate history does not turn like a door opening and closing in a single instant. It changes according to the slow rhythm of stone, air, sea, and land. Eruptions may occur in pulses, each one adding more gas and material to Earth's system. Then the oceans and atmosphere respond. The water cycle grows stronger. Regions that had once been dry begin to receive more moisture. Rain does not arrive like a disaster in one night, but like an age slowly taking shape. If we could look down upon Earth from space at that time, we would see a planet changing color very slowly. The broad seas around Pangaea absorbed heat. Above the water, more vapor rose in the ancient light. Atmospheric currents carried moisture across the sky. Winds pushed clouds deeper into lands that had once been dry. Wet seasons began to lengthen. Rains that once came and went could become more frequent, heavier, more persistent. And while the creatures below only felt each day of rain and sun, Earth on a larger scale was entering a new climate state. Scientists did not see those rains with their own eyes. No one stood beneath the Triassic sky to record the first day the clouds changed color. What remains are traces in the rocks. Sedimentary rocks are like the very slow pages of the planet. Each layer of mud, each layer of ash, each change in chemical composition can preserve part of the story. When geologists read the rock layers connected to this period, they find signals showing that the carbon cycle had been disturbed. There are changes in carbon isotopes, especially negative shifts in the carbon record, as though the atmosphere-ocean system had received an added amount of light carbon from some large source. Carbon isotopes may sound dry, but we can understand them simply as fingerprints of ancient climate. Carbon does not exist in only one form. Some carbon sources leave a different signature from others. When ancient rock layers show unusual changes in carbon ratios across many regions, scientists can recognize that something large had affected Earth's system. In this story, one of the strongest suspects is large-scale volcanic activity. The eruptions did not only spread lava over the surface, they also pushed carbon into the sky, warming the climate and drawing broad changes behind them. Beyond the carbon traces, scientists have found other signals as well, such as mercury in sediments. Mercury can be released by volcanic activity, then fall onto land and sea, and later become buried in ancient mud. When rock layers from the same time in different regions contain elevated mercury signals, it is like a reminder that the sky of that age once received material from volcanoes. We can imagine very fine ash and invisible particles traveling through the atmosphere, falling onto the sea surface, into lakes, onto lands far from the eruption site, then lying still in stone for more than 200 million years, waiting until human beings became patient enough to read them. One of the most beautiful images in paleoclimate science is the sight of researchers not seeking answers in something grand and obvious, but in thin layers of sediment. In an ancient lake, layer after layer of mud settled onto the bottom through the passing of years. Season after season, material from land, from water, from volcanic ash, and from tiny organisms accumulated into a kind of diary. Much later, when the lake had disappeared, when the continents had changed shape, when ancient lands had been lifted or buried, people sampled those rock layers and saw that the story did not happen only once. It may have consisted of many episodes, many pulses of change, like the deep drumbeats of a planet running a fever. This makes the story more frightening, but also more real. A prolonged climate event does not need to be a catastrophe continuing every single second. It can resemble a sequence of abnormal seasons repeated across many generations. One large volcanic episode warms the climate. Water vapor increases. Rain becomes more abundant. Then the system quiets for a while. After that, another pulse arrives, bringing more gas, more heat, more moisture. To the rocks, these are pulses that can be read. To living creatures, they are a world in which familiar rules slowly become less certain. Let us return to the sky of Pangaea. Before this, the hot, dry interior regions were accustomed to harsh seasons. But when the atmosphere became warmer and held more water vapor, everything above the ground began to operate more powerfully. Clouds were not just clouds. They were signs of an ocean evaporating more intensely, of air currents carrying water farther, of a planet whose heat energy was stirring the water cycle. Those clouds crossed the sky thicker, darker, more persistent. They covered the sunlight over lands that had long been used to lying exposed beneath the sun, then released rains that changed the smell of the earth. Rain in this story is the visible result of a far more invisible process. Before a raindrop fell, lava had surged up from deep within the earth. Before the lava, there had been the movement of tectonic plates and hot regions beneath the planet's crust. Before the cloud greenhouse gases had accumulated. Before the river rose, the ocean had grown warmer and the sky had held more water. Each raindrop in that age, if we could hold it in our hand, would not simply be water. It would be the final link in a chain of causes stretching from the depths of the earth to the atmosphere. Even so, we must remember that the science of deep time always walks with caution. Researchers have strong evidence showing that the Carnian period witnessed an increase in temperature and humidity, and many data connect this event with Pangaea volcanic activity. But ancient Earth did not leave a perfect record everywhere. Some regions preserve clearer evidence, while others are more obscure. Some rock layers retain the signs very well, while in other places, time has erased almost everything. So when we tell this story, we do not speak as though we had witnessed every rainfall. We speak as someone following the footprints left behind in stone, assembling each piece of evidence to glimpse the larger shape of an event. That caution makes the story deeper, because the miracle is not that we know everything, but that from very small fragments, human beings can recognize an enormous movement of the planet. A thin layer of ash says that volcanoes once erupted. An isotopic shift says that carbon once changed. A mercury signal says that the sky once received material from deep within the earth. A record of pollen and plants says that humidity once increased. When all of these signs are placed together, they are no longer scattered details. They become a very slow piece of music, in which the first deep note is the sound of volcanoes. If we imagine a night near the eruptive region, the scene would be very different from the stillness of Pangaea's interior. The sky might glow red along the horizon. The ground might tremble very slightly, as if some gigantic creature were shifting beneath it. Lava would flow in bright streams through the darkness, then cool into hard black surfaces. Hot gases would rise and dissolve into the air. Fine ash would travel farther than the eye could see. From there, the material of the Earth's interior entered the atmosphere, entered the sea, entered the rain, entered the sediments, and finally entered the geological record that hundreds of millions of years later we would call evidence. But for animals living far from the volcanoes, the first changes may have been very subtle. They did not see Pangaea. They did not know what CO2 was. They did not know the atmosphere was trapping more heat. An animal deep within Pangaea would only sense that the seasons seemed different, that the heat lasted longer, that the sky felt more humid, that the rains arrived in rhythms no longer familiar. That is the frightening thing about climate change in the natural world. The cause may lie very far away, but the consequences find their way to every river, every lake shore, every nesting ground, every path to food. And then after the eruptions, after invisible layers of gas accumulated, after quiet chemical signals entered the rocks, the sky began to grow heavy. Far from the lava fields over the dusty red plains of Pangaea, more clouds gathered. The wind carried a damp smell. The ground, long accustomed to cracking beneath the sun, prepared to hear a different sound, the sound of water falling continuously through ancient leaves, through young mud, through rivers beginning to wake. The creatures below still did not understand what was happening. They simply continued to live as they had lived, walking old paths, seeking old water sources, relying on old seasons. But above them, the climate had changed its rhythm. And when the sky changes its rhythm, no species on the ground can remain outside the story for very long. After the fiery breaths of the Earth's interior, after invisible layers of gas began to make the sky warmer and heavier, with water, Pangaea did not change in a single moment. There was no one morning when the entire supercontinent awoke and found itself transformed into another world. The change came more slowly, more silently, yet more deeply. It came through wet seasons that lasted longer than usual, through rivers that no longer dried up as quickly as before, through each rainfall striking the dry red ground and leaving a new scent in the air. The smell of wet earth, young mud, decaying leaves, the scent of a planet beginning to turn. Imagine us returning to the interior of Pangaea, where sunlight had once poured down onto cracked riverbeds and lakes shrinking into muddy pools. Now the sky is no longer as high and empty as before. Thicker clouds crawl across the horizon. Sunlight softens behind a gray veil of moisture. The wind carries a dampness with it, no longer the dry, searing heat moving over stone. Then the rain begins to fall. At first, perhaps they are only seasonal rains, but they come more often, fall more heavily, and in many places last long enough that the ground cannot return to its former state. The first raindrop falling onto dry land usually disappears very quickly. It is drawn into the cracks, absorbed by the dust, dissolved into the heated soil. But as the rain continues, the ground begins to soften. The cracks fill with water. Layers of red dust turn into dark mud. What was once a firm path across the plain may become a sinking, yielding surface, preserving the deep footprints of the creatures that pass over it. Each step now is more than movement. It is a new inscription on the land, a sign that Pangaea has begun writing its history in mud instead of dust. Rivers are among the first things the eye can see changing. Seasonal rivers, once dry for most of the year, begin to hold water longer. Small channels across the ground become streams. Streams meet and become brooks. Brooks flow into rivers. Rivers that were once gentle and shallow become muddy, wider, and stronger. Water no longer merely passes through the landscape. It pulls the landscape along with it. It carries soil, sand leaves, broken trunks, the bodies of small creatures, and fragments of a world being torn apart little by little. In low-lying regions, water gathers into new ponds and lakes. A hollow that once held only dust and stone may become a wide pool after many rainy seasons. An old basin may slowly become a shallow lake, then a marshy zone with soft, muddy banks and clusters of moisture-loving plants growing together. These places attract life because water is always the strongest invitation on a continent that had once been dry. But water is also a trap. The edges of new lakes are not as firm as dry ground. Mud can hold the legs of a heavy animal. Familiar paths around old water sources may vanish beneath slick mud. A place that was once safe for drinking may become easier for predators to ambush, or a place where a weakened creature becomes trapped while trying to cross. The forests also begin to change. Before, the long rain plants across many regions of Pangaea had endured a dry, hot, and harshly seasonal climate. But as humidity rises, areas that were once sparse may become greener. Ferns spread where the soil holds water well. Conifers and cycads are still there, but they no longer stand on the same old ground. Beneath them, fallen leaves accumulate differently from region to region. Fungi and microorganisms work. In the damp environment, roots hold mud in place, and the ground begins to smell like a wet world. Not everywhere becomes a dense forest at once. Pangaea is too vast, and climates differ too greatly from one region to another. But in many places, the new moisture opens fresh patches of green, thicker riverside vegetation, lowlands richer in plants and ecological corridors that may have been very difficult to sustain before. For animals, that landscape is both an opportunity and a challenge. A plant-eating creature, once accustomed to moving from one dry patch of vegetation to another, now has to relearn the map with its own body. The smell of plants changes. The paths change. Open stretches of land turn to mud. A small stream that could once be stepped across becomes a deeper channel. A valley once used as a seasonal migration route may now be flooded for weeks, months, or repeatedly through many wet seasons. No animal understands the concept of climate change, but they understand hunger, exhaustion, disorientation, unfamiliar water, and the feeling that the ground beneath their feet is no longer firm. We can picture a herd of ancient plant-eating reptiles crossing a plain after rain. Before, they could have walked steadily over hard ground, leaving shallow footprints that the wind would quickly erase. Now each step sinks. The young following behind may have to lift their legs higher, their bodies smaller, yet more easily exhausted. The older animals move more slowly, perhaps avoiding deep mud through the experience of many previous seasons. But that experience is no longer completely reliable. The smell of water is everywhere, but not every place with water is safe. Some stagnant pools carry disease. Some lake edges collapse. Some places are greener, but farther from familiar shelter. The world does not become easier to live in simply because there is more water. It becomes more complicated. Breeding grounds change as well. For many reptiles, eggs require an environment that is safe enough, not so dry that they die before hatching, but not flooded for too long either. In a world of irregular and prolonged rain, that balance can be broken. A raised patch of ground that had once been suitable for nesting may be overtaken by water in a new rainy season. A once stable riverbank may erode when the current grows stronger. Eggs laid too close to the water may be washed away. Eggs laid too far from food may leave hatchlings with little chance of survival after they emerge. Across generations, small differences in where nesting sites are chosen may determine which line continues and which gradually vanishes from the landscape. Rain also changes the sound of Pangaea. The earlier world had the sound of dry wind rolling pebbles feet on hard ground. Now the sound becomes thicker, water falling through ancient leaves, mud being pressed beneath heavy feet, a muddy river moving through newly eroded earth. Insects and small creatures growing more active in damp places. Tree trunks falling after water softens the soil around their roots. Even silence is different. It is no longer the silence of sunlight and dust, but a damp, low silence filled with the scent of decay and water vapor, where something may be waiting in the thicker vegetation along the river. On sloping lands, rain becomes a force of erosion. Water runs down higher ground, pulling soil and stone with it, carving new channels into the surface. Layers of soil are carried away, exposing the rock beneath. Mud flows may spill into low areas after heavy rain. Each rainy season does not merely add water to the landscape, it rearranges the landscape. Places once high may be worn down. Places once low may be filled. Riverbeds shift. Lake margins expand. Floodplains form and disappear. After thousands of years, hundreds of thousands of years, then millions of years, these small changes gather into a Pangaea very different from the hot, dry world that came before. But Pangaea does not become one unified humid forest from end to end. That is important. This supercontinent is too vast, and the distance from coast to interior is too great. Some places receive much more rain. Some become only seasonally wetter. Some regions remain strongly arid, interrupted by wet intervals. The long rain event is not a blanket of water evenly covering the entire planet. It is more like a major change in climate rhythm, making some regions much wetter. Some regions experience more violent rainy seasons, and some river and lake systems behave differently. This unevenness is what makes the ecological story so complex. A species in the right place, with the right abilities, at the right time, may find an advantage. A species trapped in a region, changing too quickly, may weaken. In the new marshlands, small life may flourish. Moisture-loving plants rise. Fern spores and other small plant forms spread through the air. Lakes and damp shorelines create space for freshwater creatures, ancient insects larvae, and many forms of life too small for the eye to easily notice. They are not the great characters of our imagination, but they are the foundation of the entire ecosystem. When small creatures change, the food of larger creatures changes as well. When plants change, plant eaters change with them. When plant eaters change, predators are also forced to change. A rainfall on the land does not simply wet the surface. It touches every invisible thread connecting living things to one another. Let us pause beside a riverbank after many days of rain. The muddy water moves heavily, carrying the reddish-brown color of soil eroded from far away. Along the bank, ancient tree trunks lean toward the water. Their roots are exposed because the softened soil has been carried away. A small animal runs quickly across the mud, leaving a delicate trail before vanishing into the bushes. Farther away, a large creature bends down to drink, but it does not remain still for long. The riverbank is no longer a peaceful place. The current may change direction. The mud may collapse. A predator may hide behind new patches of thicker vegetation. Water brings life, but it also brings instability. In that world, the memory of the landscape is constantly being erased. Footprints made today may be blurred by tomorrow's rain. A trail formed over many generations may be cut across by a flood. A new lake may attract an entire region of animals, then change again as sediment fills it. Animals no longer move through a fixed map. They move through a soft, wet world that is rewriting itself. And within that change, life has no right to stand still. Rain also makes time on the land easier to preserve. When soft mud receives footprints, when water carries sediment over the surface, when lakes and marshes settle into layer upon layer of material, Earth begins to record more. Footprints may press deeply into the ground and then be buried. Fragments of plants, pollen grains, spores, ancient soils, layers of mud, all can remain in stone. What living creatures experienced only as a difficult season later becomes evidence for us. Thanks to mud, thanks to sediment, thanks to layers of earth arranged by water, the ancient rain does not vanish completely from history. There is a very quiet beauty in that thought. An animal walking along a lakeshore 230 million years ago does not know that its step may become a signal sent into the future. It is only trying to find its way through mud. It only wants to reach food or avoid a predator. But the damp ground preserves that moment. Then another layer of mud covers it. Then time presses it down. Then the continents change shape. And much later, human beings look into stone, into sediment, into fossil traces, and understand that there was once a time when Pangaea was no longer as dry as before, a time when water moved across the land with enough power to alter ecosystems. The long rain does not only fill rivers and lakes, it changes how light falls upon the land. When clouds become more common, harsh sunny days may be divided by the gray shadows of the sky. When plants grow thicker in damp places, the ground receives more shade. When the soil holds water longer, the smell and color of the landscape change. From a distance, a plain that was once red and empty may begin to show green bands along rivers, pools of water reflecting the sky, and dark patches of mud like ink stains on an ancient map. Pangaea is no longer only the supercontinent of sundust and distance. It becomes a place where water begins to redraw the lines. For animals, this transformation unfolds slowly but without mercy. There is no single day of apocalypse. There is no one flood that sweeps everything away. What happens is more frightening in its quietness. The old normal is no longer normal. The dry season is not as dry as before. The rainy season is not as short as before. Rivers do not keep their old courses. Plants do not grow exactly as they once did. Feeding grounds, shelters, nesting places, migration routes, all are drawn into a great adjustment. Each species must answer with its own life. And as we move slowly through Pangaea in this chapter, we can feel clearly that the main character is not one particular animal, but the ground itself. The ground is softening. The ground is moving away. The ground is preserving footprints, feeding roots, opening new lakes, collapsing riverbanks, hiding danger, creating opportunity. The rain does not only fall from above, it enters every crack in the soil, every current, every layer of mud, every root zone, every place where a living creature bends down to drink. It turns climate into landscape sky, into river water, vapor, into fate. By the end of this period, Pangaea no longer fully resembles the world we saw before the rain. The lowlands are wetter, the rivers are stronger, the lake margins are wider. New patches of vegetation have opened. Old routes of movement are cut off or bent around the water. Life continues, but it must continue in a landscape that has changed. Some creatures find new places of shelter. Some are pushed out of their familiar rhythms. Some simply follow the water, the plants, the prey, until they no longer know what the old world once was like. And then, as water flows away from the land, it does not stop at rivers and lakes. The muddy currents continue to carry silt minerals, dead leaves, nutrients, and traces of the continent toward lower and more distant places. The story of rain on Pangaea, therefore, does not end on land. Everything washed from the riverbanks, from the humid forests, from the muddy plains, will eventually travel into a far wider space where the ancient sea waits to receive everything the continent sends down. Imagine us standing at the mouth of an ancient river. Behind us lies a Pangaea wetter than before, with red soil softened by rain, with roots gripping the mud, with lowlands flooded after many long rainy seasons. Ahead of us is a shallow sea opening beneath a gray sky. The river is not clear. It carries a reddish-brown color, the color of soil, eroded from far away, the color of mud, sand minerals, and organic fragments. The river water pours into the sea like a dense plume of smoke, spreading beneath the surface, dimming the light, weighing down the seafloor, and carrying with it a volume of material that marine ecosystems were not always ready to receive. In shallow seas where sunlight once pierced down to the seabed and nourished many communities of life, turbidity could change everything. The light weakened. Creatures that needed clear water to live, to filter food, to cling to rock or carbonate surfaces began to feel pressure. Fine layers of mud slowly settled, covering the seafloor like a heavy cloth. For a fixed organism, just a few continuous layers of sediment could become a serious challenge. It could not simply stand up and move elsewhere, like an animal on land. It could only endure the current, endure the mud, endure the changes in the environment around it. The ancient ocean, during this time, was not like the modern sea we know. There were no whales crossing the surface. There were no colorful modern coral reefs like the ones we see in tropical films today. The Triassic marine world had its own groups of organisms, life forms, that had recovered after the end Permian mass extinction and were rebuilding ecosystems in their own way. There were bottom-dwelling organisms, filter feeders, mollusks, shell-building creatures, marine predators, and communities living around rock surfaces, carbonate banks, and shallow marine shelves. Together they formed a silent network beneath the water where light, clarity, oxygen, salinity, and nutrients all mattered. When rainfall increased on land, the sea received more nutrients from rivers. At first, this may sound like a good thing. Nutrients can feed plankton and help some small life forms flourish. But in the ocean, too much of a good thing can also become dangerous. When more nutrients pour in, tiny organisms can bloom in the water. When they die, their bodies sink and decompose. That process consumes oxygen. If the amount of organic matter is too great, if the water is not mixed enough, if the sea becomes stratified, oxygen in deeper layers can decline. And when oxygen declines, the seafloor becomes a difficult place to live. Picture the sea surface from above. It may still look quiet, even beautiful. Rain falls in fine streaks across the water. Low waves slide toward the shore. But below, in the darker and more turbid water, a kind of tension is unfolding. A bottom-dwelling organism opens itself to filter food, but the water carries too much mud. A small community on a carbonate surface is buried beneath fine sediment. Creatures that need oxygen near the bottom begin to slow. Some leave if they can. Some cannot leave. Some die and become another thin layer within the sediment. That is what makes the ocean, during the long rainy age, so important. The sea did not merely reflect climate, the sea recorded climate. In ancient marine rocks, people can see the shift from brighter carbonate rocks to layers richer in material from the land. They can see intervals when carbonate platforms declined, when systems that had once built limestone foundations in shallow seas no longer developed as they had before. Those carbonate platforms needed fairly stable conditions, water clear enough, chemistry suitable enough, and not too much mud. But when land eroded more intensely and rivers delivered more material into the sea, that environment could be disrupted. Think of a carbonate platform as a slow city beneath the sea. Not a city made of human brick and stone, but a structure gradually built by organisms, minerals, shells, carbonate mud, and chemical processes. It does not rise in a single day. It needs time, relatively clear water, and a stable rhythm of life. But if rivers begin constantly sending in mud and sand, if light decreases, if the chemistry of the water changes, that slow city can stop growing. Some parts are buried. Some of the organisms that built it weaken. And in the rock record, that decline becomes a sign that the sea had been pulled into the climate event of the land. In deeper marine regions, the story does not unfold through visible mud as clearly as it does at a river mouth, but through chemistry and oxygen. As the climate warms, warmer seawater tends to hold less dissolved oxygen. If the ocean becomes strongly stratified, deeper water may have difficulty receiving oxygen from the surface. If at the same time more organic matter sinks downward because biological productivity has increased, oxygen in the depths is consumed even more. The result is that some marine regions may fall into a state of low oxygen, or even near absence of oxygen at the seafloor. For marine life, this is not a small change. Oxygen is the boundary between a place where life can continue and a place where only silence remains. In the darkness of deep water, a small creature swims slowly through a sea that is changing. It does not know what volcanoes are. It does not know that rain on Pangaea has made the rivers more turbid. It does not know that the climate is warming. It only feels that the water around it is heavier, different, less favorable. Species sensitive to oxygen, to water, clarity to water composition, and to breeding conditions begin to be pushed out of their familiar ranges. If they find better water, they continue. If not, their line may gradually fade in the fossil record. There were groups of marine organisms in the Triassic that came under great pressure during this period. Some ammonoids, crinoids, bryozoans, conodonts, and shell-building organisms, or those dependent on stable marine environments, may have been affected in many regions. We do not need to turn this chapter into a list of scientific names, because what matters more is understanding the mechanism when the sea changes too quickly for organisms to adapt. Creatures that had been highly successful under old conditions can become fragile, not because they are weak, but because the world beneath them has changed its foundation. A crinoid, if we imagine it, simply resembles a creature of quiet beauty, beneath the sea, fixed to the bottom and extending its soft arms to catch food drifting through the water. In clear water, with the right current, it can live like an ancient flower under the sea. But if mud settles over it, if the water becomes more turbid, if oxygen declines, if the current carries too much fine material, that beauty becomes fragile. A layer of sediment does not need to intend to kill anything. It only needs to fall for long enough. An ammonoid with its coiled shell and soft body within could swim through the Triassic Ocean like a familiar shadow of the ancient sea. But changes in the food chain temperature, oxygen, and water chemistry could affect even more mobile organisms. When the base of small life in the sea changes, the creatures that feed on it change as well. When favorable waters shrink or shift, organisms must migrate, adapt, or disappear from certain regions. The ocean is vast, but not every part of the ocean is the same. For a species that requires specific conditions, the immense sea can also become a maze. There is one very important point to keep in mind. The long rainy age did not turn the entire ocean into a dead zone. Life still existed. Many organisms still reproduced, swam, hunted filtered water, clung to the seafloor, and built new communities. But the ecosystem was disturbed. Some places declined sharply. Some places changed in their biological composition. In some regions, older groups lost their positions, while other groups later had opportunities to expand. The ocean was not completely silent. It was like a piece of music whose rhythm had been altered, where some older sounds faded away and some new sounds began to appear, though the listener would have to listen very deeply in the rocks to recognize them. Let us return to the river mouth. After many rainy seasons, the nearshore sea is no longer the same. The plume of turbid water spreads farther. Mud settles in thin layers. Tiny organisms in the water change according to the amount of nutrients. Farther offshore currents disperse material, carrying traces of the continent deeper into the sea. What began as rain on leaves on red soil on the riverbanks of Pangaea eventually became an oceanic event. This is the frightening beauty of Earth. No part is truly separate. The interior of the Earth breathes out gas. The gas changes the rhythm of the sky. The sky makes rain fall. Rain makes rivers rise. Rivers make the sea change. And the sea, though it seems far from the land, must also answer. In ancient marine rocks, that answer is preserved in very small signs. A rock layer has fewer fossil shells. A sedimentary interval shows carbonate decline. A chemical signal suggests low oxygen, a disappearance or weakening of groups that had once been common. These things are not as loud as thunder, not as large as dinosaur footprints, but they are evidence of a crisis. The ocean does not tell stories with a voice. It tells them through absence, through species that no longer appear in the next layer of rock, through communities that are not rebuilt as they once were, through quiet gaps between two ages of life. If we were to swim slowly through a shallow sea during that age, the light would be different. Near the river mouth, the water might be brown and murky. Tiny particles would drift through it, making every outline softer and more distant. The seafloor would no longer be clearly lit. Bottom-dwelling organisms would appear like blurred shadows. Some would still be alive, still opening themselves to the current. Some would already be half buried in mud. Farther away, where the water was a little clearer, swimming creatures would pass like dark streaks. The space would not be dead, but it would be tense like a room gradually losing air, while every creature inside was still trying to breathe slowly enough to survive. In deeper waters, the scene would be even quieter. No rain would fall there directly. No river would roar aloud. There would only be darkness, water pressure, and fine sediment settling from above. Yet that quiet place could record periods of low oxygen very clearly. When fewer organisms burrowed into the seafloor, sediment layers could remain thinner, more even. When organic remains did not fully decompose in oxygen-poor environments, the rock could carry a different signal. A decline in life does not always create a violent scene. Sometimes it creates a cold orderliness in the sediment. This is what makes the ocean chapter an indispensable part of the story. If we look only at land, we see rain-mud forests and animals finding their way through a new landscape. But when we look down into the sea, we see that the event reached much deeper. It touched the chemistry of the water. It touched the foundation of the food chain. It shook communities that had existed on marine shelves. It turned rivers into giant conduits, linking continental climate with marine life. And in doing so, it shows that Earth is not made of separate stages, but of a single system where a change in one place can echo very far away. A marine creature living thousands of kilometers from the volcanic region, very far from the riverbanks of Pangaea, may still have been affected by what happened on land. It did not see lava. It did not hear rain falling on conifer leaves. It did not feel mud beneath its feet the way land animals did. But the water around it had changed. Its food had changed. Its predators or prey had changed. The place where it reproduced, where larvae drifted with the currents, where its shell formed, all could be touched by chains of cause, stretching from the depths of the earth to the deep sea. And so, the long rainy age was no longer just a story with beautiful images of clouds and water. It became a lesson in connection. Rain does not only fall. Rain moves. Rain carries material. Rain changes currents. Rain changes the color of the sea. Rain nourishes some small forms of life and suffocates others. Rain helps some regions become richer, but can also destabilize some marine communities. In every drop of water flowing from Pangaea into the ocean, there is a tiny part of the continent, of the climate of the volcanoes, and of the future of life. At the end of this chapter, let us imagine standing on an ancient headland overlooking the sea. Behind us lies a wetter land than before, with rivers carrying the color of red mud. Before us stretches the wide ocean, its surface seeming calm, while beneath it changes are unfolding that ordinary sight cannot see. Tiny organisms die and sink. Carbonate platforms slow their growth. Low oxygen waters expand in some regions. Older communities begin to fracture, and the sea, like the land, is learning a new climate rhythm it never chose. But the ocean does not only lose. After every great disturbance, life often leaves behind empty spaces. Those spaces can be frightening for organisms living in the present, but over long periods of time, they become places where other lineages can step in. In this chapter, we have not yet gone deeply into the survivors, because that story needs a space of its own. Here we have only seen the marine environment pulled into the spiral of the rainy age murkier water. a changing seafloor, possible declines in oxygen, and biological communities placed under new pressure. And as night falls over the Triassic Ocean, rain still falls somewhere on land, rivers still flow, mud still settles, the sea still receives thin layer after thin layer of material from Pangaea. There is no great cry announcing a crisis. There is no clear line between before and after. There are only slow changes repeated again and again, long enough to make some organisms disappear from the rock record, deep enough to keep the marine ecosystem from ever returning exactly to what it had been. And from that silent transformation, the largest question of the story begins to appear more clearly. When land changes, when the sea changes, when water touches every ecosystem, from riverbank to ocean floor, which animals can continue, which creatures are flexible enough to live through a world that is wetter, muddier, murkier, and harder to predict. And which ones, though? They had once been highly successful in the old world will gradually be left behind as Earth rewrites the rules of life. When we say that animals survived the long age of rain, we should not imagine a single lonely creature curled inside a cave waiting for the storm to pass. 2 million years is far too long for any individual life. No animal lived from the beginning to the end of that period. No creature woke on the first day of rain and was still there when the sky slowly began to dry again. Survival in this story was not about enduring one cold night, one storm season, or one single flood. Survival meant an entire lineage, continuing through countless breeding seasons, countless fragile generations, countless times when the environment changed until its name was still recorded in stone, or at least its shadow remained within later branches of evolution. Let us return to Pangaea during the Age of Rain. The ground is no longer as firm as before. Rivers rise and then change course. New lakes appear in the lowlands. Humid forests grow thicker along the water. Mud preserves deeper footprints, but it also swallows slower steps. In this place, survival no longer belongs only to the species with the strongest jaws or the largest bodies. A body once perfect for a hot, dry world may become inconvenient in a world of mud. A behavior that once helped a species survive the dry season may become a burden when the wet season lasts longer. And a small creature, seemingly insignificant, may gain an advantage simply because it is lighter, more flexible, able to eat more kinds of food, or better at moving through lands cut apart by water. In the newly expanded freshwater regions, some species may have found opportunity. Rain created more ponds and lakes widened marshes and helped low-lying areas hold water for longer. For creatures tied closely to water, this could have felt like a door opening. The large amphibians of the Triassic, including groups that live near lakes and rivers, may have taken advantage of these new humid environments. We can imagine a large-bodied amphibian lying near the edge of murky water, its skin damp, its eyes rising above the surface, almost blending into the mud and decaying leaves. It did not need to travel far, like species living on dry land. As water spread, its world spread with it. New currents brought small prey. New marshes became shelters. For a time, rain may not have been a disaster for it, but a condition that helped it continue to exist. Yet even for species that benefited from water life, did not become completely easy. New water could arrive too quickly. New lakes could dry out or become filled with mud. A river might change direction, leaving behind stagnant areas, poor in oxygen, or overloaded with decaying material. A place once full of food could become a trap when the season shifted. So, survival in the age of rain was not simply about loving water or living near water. It was the ability to keep pace with the changing behavior of water. Any species too tightly dependent on one kind of lake, one kind of shoreline, or one kind of breeding season could still be endangered when the rhythm of the climate was no longer what it had been. On land, the story was more complicated. Large and widespread plant-eating animals from the world before the rain faced a new reality. Plants did not vanish, but their composition and their locations changed. Old vegetation zones could be flooded. Some drought-tolerant plants no longer dominated in wetter places. Ferns and moisture-loving plants could spread across the lowlands. Riverside forests grew thicker, but not every plant eater could use the new food sources in the same way. The body of a plant-eating species is the result of millions of years of fitting into a particular kind of food, a particular kind of chewing, a particular kind of digestion, a particular kind of movement. When the vegetation changed, that entire body was placed under examination. Picture a group of rhynchosaurs, plant-eating reptiles that had once been highly successful in many Triassic environments. They lower themselves over damp ground using powerful jaws to process hard and fibrous plant material. But around them, the world is changing season by season. Plants grow in different places. Old riverbanks erode. Lands that had once been dry and easy to cross now become mud. The young must follow the herd through swampier ground, where every step costs more energy. Food still exists, but it is no longer distributed as it once was. A species may not die because of one rainfall, but it can weaken when many seasons in a row make its food habitat and travel routes no longer match the body it has. For Dicynodonts, ancient creatures left over from earlier periods, that feeling was almost like a final test from the past. They had already survived great upheavals in Earth's history. They were enduring shadows, heavy-bodied, and slow-moving, seeming to belong to a world older than the one around them. But surviving one catastrophe does not mean surviving forever through every change that follows. When the environment shifts from dry to wetter, when ecosystems rearrange themselves, large, slow-moving creatures dependent on certain food sources and habitats may come under more pressure than smaller, more flexible animals. Not because they fail immediately, but because each generation has to pay a small additional price for a world that looks less and less like the world their ancestors knew. Perhaps on a gray afternoon, a large Dicynodont stands at the edge of a new lake. The water glimmers in the weak light. Mud clings around its feet. It bends down to drink slowly, unaware that a few generations earlier, this place may have been only dry ground. Behind it, ancient shrubs have changed position, growing thicker in wetter areas. Before it, the lake edge is soft and unstable. It still lives, still breathes, still eats, still passes through. That day. But history does not only ask whether one individual can survive one day. History asks whether that entire lineage can give birth, raise young, find food, and maintain its numbers long enough in a changing world. Predators also had to adapt. A predator cannot survive if its familiar prey declines or changes its routes. In the drier world before rare water sources may have helped predators predict where prey would gather. But when water appeared in more places, the map of hunting changed. Prey could spread out across many new humid regions. Thicker riverside forests could create better ambush sites, but also reduce visibility. Mud could hold scents and footprints, but also make pursuit more difficult. A heavy predator might be disadvantaged in swampy ground, while a smaller, faster one able to exploit more tangled terrain could find opportunity. Within the broad group of archosaurs, there were many different kinds of creatures. Some were frightening predators on land. Some lived closer to water. Some carried traits that would later be linked to the crocodile line. Others belonged to the branch leading toward dinosaurs. This moment was not a stage with only one victorious character. It was a wide ecological chessboard where many groups were testing different ways of life. Some remained strong for a time, some came under pressure, some found open space. And that diversity is what makes archosaurs such an important part of the story. Not all survived in the same way, but in a changing world. Lineages with many ways of living often had more chances. One major secret of survival in the age of rain was flexibility. Flexibility does not always look majestic. It may lie in a smaller body that requires less food. It may lie in the ability to eat many kinds of plants or prey. It may lie in moving quickly across lands divided by new rivers. It may lie in reproducing faster, so that even if many young die, enough of the next generation remains. It may lie in living along edges, the edge of a forest, the edge of a river, the edge of a marsh, where many sources of food meet and the environment changes constantly. In a stable world, a specialized species may be extremely successful. But in a world whose rhythm has changed, a flexible species often has more paths to survive. Small creatures were perhaps the quietest characters in this chapter. They did not leave behind enormous skeletons to astonish people in the future. They did not create the noble image of great predators. But in a time of upheaval, small size could be an advantage. A small animal needs less food. It can hide in tree hollows beneath roots in rock cracks along muddy banks. It can change shelters more quickly. It can live on insects, seeds, shoots, organic remains, or food sources that larger animals cannot use efficiently. When a river cuts across a stretch of land, a small creature may find a detour where a larger creature is stopped. When humid forests grow thicker, it can turn that tangled world into concealment. We can imagine a small creature running across the floor of a humid forest near dusk. The rain has just stopped. Ancient leaves drip water onto the mud. A larger animal passes by, leaving a footprint as deep as a shallow pit. The small creature slips along the edge of that footprint, pauses beneath a root, listens, then runs on. It dominates nothing. It does not shake the ground. But sometimes life continues through forms like this, light, hidden, difficult to see, yet quick enough to avoid death and flexible enough to find food in an unstable world. The first dinosaurs must also be seen in this light. They were not yet the giant, long-necked sauropods or the great predators of later ages. At this point, many dinosaurs were still relatively small, fast, and only one part of a much broader living community. But that very modesty may have helped them. A lighter body made it easier to move across many kinds of terrain. Walking on two legs in some forms may have supported speed and the ability to cross open ground. Moderate size reduced food demands compared with larger animals. They did not need to be rulers in order to survive. They only needed to remain present, keep reproducing, and continue stepping through the openings created by environmental change. During the long age of rain, survival did not happen only where water was abundant. It also happened in transitional zones, the edges of marshes, the edges of forests, riverbanks, uplands near lowlands, places that were not fully dry but not fully flooded either. These were places rich in opportunity but also full of danger. Food might be more abundant, but predators could appear more easily. Water might be nearer, but the mud could be deeper. Plants could provide cover, but also make movement harder. Species able to live in these edge zones and tolerate many different conditions often had an advantage when the climate fluctuated. Another important point is that survival may have required migration. When old habitats no longer fit species capable of traveling far, expanding their ranges or following new river and lake corridors could find better places. But migration in a wetter Pangaea was not simple. New rivers could be pathways, but they could also be barriers. Humid forests could connect habitats, but they could also hide danger. Higher ground might be safer from floods, but hold less food. Lowlands might have more food, but also more flooding and disease. Every movement was a gamble, and that gamble was repeated across generation after generation. Rain could also make disease and parasites more important. In humid environments, fungi, microorganisms, and small life forms could develop differently than in dry conditions. More plant matter decayed. Stagnant water could become a place where pathogens gathered. Animals clustering around water sources or new vegetation zones could spread disease more easily. This is very difficult to see directly in the fossil record, but in the natural world, humid environments always bring invisible biological pressures. A species did not only have to find food and avoid being hunted, it also had to endure things so small that they left no footprints yet could decide the health of an entire population. Still, this story should not be told as a simple straight line. This species lost, that species won. The reality of ancient life was far more complex. A species could decline in one region but remain in another. A group could be affected during one stage but recover later. Some life forms did not leave enough fossils for us to fully understand their fate. What we have are fragments, bones, footprints, sediments, pollen rock layers, the appearance and disappearance of groups of organisms. From these pieces, we can see a larger picture. The long age of rain changed the rules of the game, and life had to answer by adapting, moving, changing, or disappearing. One of the deepest images of this chapter is a muddy surface after rain. Across it, many footprints overlap. The footprints of a large plant eater, deep and heavy. The footprints of a smaller creature, lighter, crossing sideways. The dragging trace of a low body. The claw marks of a predator passing along the water's edge. Some tracks stop at the riverbank. Some continue to the other side. Some are erased by water before they can become fossilized. Some are covered by new mud and preserved. That muddy ground is like a silent record of survival, many species crossing the same changing world, but not all leaving traces that last. And perhaps that is the way we should understand this age. There was no ark of rescue, no safe shelter for all. No animal was guaranteed to continue simply because it had once succeeded in the past. Each lineage had to find its answer within its own body. Species living near water answered by using lakes and marshes. Plant eaters answered by following new vegetation, or weakened if they could not keep up. Predators answered by changing prey, changing ambush sites, changing movement rhythms. Small creatures answered through secrecy and flexibility. The first dinosaurs answered through persistent presence, quietly stepping through the edges of the story. When we look at Pangaea during the Age of Rain with slow eyes, we will see that survival was not one single, powerful act. It was millions of small, unconscious choices. A mother choosing a nesting place just a little higher. A herd of plant eaters changing direction because a riverbank had collapsed. A predator learning to ambush near the humid forest instead of the old lakeshore. A small creature leaving its shelter before the water rose. These choices were not recorded as personal stories, but their consequences accumulated into evolutionary history. The lineages that chose correctly or were lucky enough to meet the right conditions continued. The lineages that could not change in time slowly thinned away, and sometimes in the history of Earth, simply continuing is the greatest miracle of all. After the long age of rain, Earth did not return exactly to what it had been before. Water may have withdrawn from many lowlands. Mud may have slowly dried beneath the sun. Rivers may have found a steadier rhythm of flow once again. But a world that had been changed for millions of years could not simply wipe the ground dry and continue as it once had. Migration routes had changed. Forests had changed. Lake margins, marshlands, vegetation, and even the communities of life that had once lived there had all been rearranged. When the rain softened, what remained was not the old world, but a new Pangaea where many places in nature were waiting to be filled. Imagine an afternoon after many long, wet seasons. The sky is no longer as heavy with rain as before. Sunlight returns over a broad field of mud where the water has just withdrawn and left behind soft ground, faintly cracking beneath the heat. Across that surface, there are many footprints. There are large, deep tracks belonging to heavy plant-eating animals that had passed through the shallow water. There are dragging marks left by low-bodied creatures. There are claw prints from predators. And among all those traces, there are smaller, finer footprints moving to a different rhythm. They do not impress by their size, but they carry something more important, the increasingly frequent presence of the first dinosaurs. Dinosaurs did not appear out of nothing after the rain. They had already been present before in the Triassic world, but they were not yet the dominant group. They lived alongside many other ancient reptiles, alongside predatory archosaurs that were not dinosaurs, alongside rhynchosaurs, dicynodonts, and creatures that had once been very well suited to the earlier, hot, dry environment. If we had stood in Pangaea before the age of rain, we might easily have overlooked the dinosaurs. They were often smaller, less striking, and seemed to be only one among many branches of life trying to exist. But history does not always begin with the creature standing highest. Sometimes it begins with those at the edge of the story, waiting for a new world to open. The Great Rain did this in a very slow way. It did not place a crown upon the heads of dinosaurs. It did not choose one group of creatures and hand them dominion. It simply changed the environment. But in nature, once the environment changes, an entire order can begin to shift. Species that had once been highly successful in the old climate could weaken when food habitat and reproductive rhythms were no longer the same. Large, slow species too deeply specialized for a particular way of life could struggle when the landscape kept changing. And as some older groups gradually became less common, ecological gaps began to appear. An ecological gap may sound like a dry concept, but if we look at it through imagery, it becomes very alive. Imagine a plain once filled with large plant eaters feeding in familiar areas. When they declined, part of the food supply was no longer used in the same way. A riverside path once crowded with the footprints of older groups became emptier. A patch of young plants that grew after a flood had no species fully exploiting it yet. A predator that lost its familiar prey had to change the way it hunted or disappear from that region. In those quiet openings, other creatures could step in. Not because they were stronger in every way, but because they were better suited to the new situation. For the first dinosaurs, their advantage may have come from many small traits added together. Many early dinosaurs had relatively light bodies, agile movement, and legs positioned more directly beneath the body than many sprawling reptiles. Holding the body higher off the ground in this way helped them move more efficiently and conserve energy in many circumstances. A light and quick animal could cross open ground, avoid deep mud, change its route when rivers cut through old paths, and keep pace with food sources or prey that were shifting across the landscape. In a world after upheaval, small advantages like these could become very important over many generations. Picture a small dinosaur stepping across damp ground after rain. Its belly does not drag close to the earth. It does not have to lift a body too heavy out of the mud. Its legs stand beneath its body, moving quickly and lightly, leaving footprints that are clear but not too deep. It pauses, raises its head, listens to the sound of distant flowing water, then continues through a low strip of vegetation along the river. It does not know that its body may be a good answer to the new age. It is only searching for food, avoiding danger, living through the day. But those ordinary days repeated over countless generations are where evolutionary history changes in silence. Some early dinosaurs were small or medium-sized meat eaters, hunting smaller prey along the edges of forests and plains. Other lineages gradually moved toward plant-eating or omnivorous ways of life, making use of food sources that were changing in the post-rain ecosystem. What mattered was not that they immediately occupied every role, but that they had the ability to expand into many different ways of living. When a group of organisms can try many forms of existence, its chances increase. One branch may fail, while another fits better. One species may vanish in one region, while its relatives flourish elsewhere. Meanwhile, some older groups came under pressure. Rhynchosaurs, once very widespread in many Triassic ecosystems, declined strongly afterward. Dicynodonts, those enduring ancient creatures, also gradually lost their place in many regions. Non-dinosaur archosaurs remained important, but the chessboard had changed. When groups that had once occupied much ecological space weakened life, did not leave those spaces empty forever. They were gradually filled by creatures whose bodies' behaviors and rhythms of life better matched the conditions after the upheaval. Dinosaurs were one of the groups that managed to take advantage of that opportunity. But we must speak carefully. It was not one rain event alone that made dinosaurs dominate Earth. The rise of dinosaurs was a long and complex process stretching through many stages of the Triassic and beyond. The Great Rain may have been a turning point, a push, a rearrangement of ecosystems. But there were many other factors as well: later climate conditions, competition with other archosaur groups, later extinction events, changes in vegetation, the expansion of habitats, and the evolutionary abilities of dinosaurs themselves over time. If we imagine history as a long road, the Age of Rain was not the whole road. It was an important bend. After the rains diminished, many regions of Pangaea became drier again. This may sound paradoxical. The rain helped open opportunities, but the return of dryness afterward may also have contributed to the selection of life. Species that benefited only in humid marshes could lose their advantage when the climate shifted again. Creatures that could endure humid conditions and also move into drier lands had greater opportunities. Early dinosaurs may have benefited not only because they survived the rain, but because they could continue expanding when the post-rain landscape shifted into other kinds of environments. They were not trapped in a single world. Imagine Pangaea after the wet period as a land marked by new scars. Rivers had recut the plains. Some dried lakes had left behind soft layers of sediment. Riverside forests remained in some regions, while elsewhere the land became drier and more open again. Across that ground, animals moved through a world both familiar and strange. Older groups still remained, but they were no longer as secure as before. Newer groups had not yet taken control, but they had more chances to appear in more places. And in later rock layers, dinosaur footprints began to become more noticeable, like fine strokes of ink repeated again and again across the pages of Earth. Footprints are a very special kind of evidence. Bones tell us where a creature died, or at least where its remains were buried. But footprints tell us that the creature lived there, walked there, and placed the weight of its body upon the ground in one specific moment. A dinosaur footprint in Triassic mud is not merely a hollow mark. It is a second of life. When dinosaur footprints appear more often in certain geological records, they suggest that these creatures were no longer only rare shadows. They were becoming a clearer part of the landscape, A muddy surface can preserve many footprints from many different species. Over time, if the footprints of one group become more common in younger layers, it is like hearing the footsteps of that group grow louder in history. We do not need to imagine them seizing everything in a single day. It is enough to see them appearing more often, becoming more diverse, occupying more environments, and we understand that the balance is changing. Dinosaurs rose in that way, not noisily, not suddenly, but through the steady repetition of footsteps across generations. The dinosaur body also contained clues to later success. A more upright stance beneath the body helped them avoid spending energy in ways that many lower, more sprawling reptiles may have done during long movement. This was especially important on a vast supercontinent where food and water could be distributed very differently by season and region. A creature that could move more efficiently had an advantage when it needed to travel far to find food, avoid dry regions, or leave places altered by floods and mud. Across many generations, a small advantage in movement could become a large advantage in expanding territory. In addition, dinosaurs did not have only one body type. Over time, they branched into many different forms. There were small, fast predators. There were plant-eating forms beginning to adapt to new food sources. There were lineages gradually moving toward larger bodies. This diversity was very important because the more ways of living a group has the more chances it has to find a place to survive when the environment changes. After the rain, the world did not offer only one empty space. It opened many edge zones, many food sources, many kinds of terrain, and many climate rhythms. Dinosaurs gradually entered those spaces through many different paths. However, in this chapter, we should not look at dinosaurs as victors who already knew their destiny. At that time, they did not know that tens of millions of years later, their descendants would include long-necked giants, crossing Jurassic plains, great predators standing at the top of the food chain, or winged creatures flying through the sky in the form of birds. They knew nothing of future glory. They were simply living creatures in their own present among mud plants, water sunlight predators, and prey. What made them special was not that they were destined to dominate, but that they had enough conditions to avoid disappearing when the world changed direction. Perhaps on a morning after rain, a small dinosaur moves through land beside a river. Thin mist still rests over ancient shrubs. The ground is soft, but no longer flooded. Farther away, a group of large plant-eating reptiles moves slowly toward low vegetation. A predator that is not a dinosaur lies still in the shade, still as dangerous as at any earlier time. The world does not yet belong to dinosaurs, but every step taken by that small creature shows that it is present in a story that is expanding. It lives among things stronger, larger, older than itself, but it is not erased from the picture. And that is the most subtle point in the rise of dinosaurs. Before they could dominate, they first had to persist. Before becoming symbols of power, they had to pass through difficult seasons like every other creature. Before leaving enormous skeletons in the human imagination, they left small footprints in mud. Dominance did not begin with a roar. It began with enduring presence, with the ability to survive, as other groups weakened with the use of each small opening the environment created. When the Great Rain shook the old world, it also made the future more changeable. Older plant eaters declined, leaving behind food and space. Disturbed ecosystems created new habitats. Predators had to adjust. Small, flexible creatures had opportunities to expand. Within that movement, dinosaurs were not the only characters, but they were one of the groups that found one of the clearest paths upward. They entered those gaps not in one giant leap, but through countless small steps across countless generations. After the Age of Rain, Pangaea was like an old house that had just been rearranged. Some rooms were still there, but the doors had changed places. Some corridors were blocked by mud, by rivers, by new forests. Some open spaces appeared where other creatures had once occupied them. Species accustomed to the old layout could become confused. Species flexible enough to learn the new layout could go farther. Dinosaurs were the ones that learned how to move through that changed house. They did not need to break everything apart. They only needed to find a way through. Then time continued to pass. Each season left a thin layer upon the land. Each generation was born, grew, died, and became a very small part of the fossil record. Dinosaurs were gradually no longer lonely footprints. They appeared more often, became more diverse, and in later stages would become the great figures of the Mesozoic. But in this chapter, we are standing at the moment before that glory became truly clear, when everything was still moving slowly. This is the moment when the sound of rain had softened the mud, was drying, and on the ground a new order was beginning to form without anyone needing to name it. As our journey reaches its final chapter, let us step away for a moment from the damp mudflats, the muddy red rivers, the ancient forests thick with moisture, and the dinosaur footprints still pressed into the soft ground. Let us pull back farther and farther, until all of Pangaea becomes a vast body of land lying beneath the ancient sky. From that distance, Earth is no longer a place standing still. It feels like a very old living being, changing its own skin through fire, from within water, from above stone, beneath the feet, and life still trying to cling to every small opportunity. At first, that world was overwhelmingly hot, dry, and immense. Ancient animals had grown used to its rhythm. They knew where water could be found, which seasons demanded movement, which regions held food, and which places were dangerous. That order seemed durable, as if it might continue forever. But then from deep within the earth, volcanoes began to awaken. The climate grew warmer. The sky held more water vapor. Rains came more often. Rivers began to rise. The ground began to soften. The seas began to change color. And little by little, the familiar world of those animals was pulled into a very long trial. The most remarkable thing about that rainy age was not only that rain fell across a span of time, almost impossible to imagine. That image is powerful, but behind it lies a much larger story. This was not merely a story of bad weather. It was the story of how Earth changed from the inside outward. Fire from the planet's depths altered the sky. The altered sky brought more rain. Rain changed the rivers. The rivers carried mud minerals and tiny forms of life into the sea. And then, from land to ocean, every living creature had to learn how to live in a world that no longer resembled yesterday. Before the long rain began, many species had once been highly successful. Plant-eating reptiles, such as Dinosaurs, had appeared in many places. Dicynodonts, ancient and enduring creatures, still moved slowly across the land like surviving shadows of an older age. Non-dinosaur archosaurs still played important roles in the predatory world. Beneath the sea, communities of life were also gradually recovering from even older catastrophes in the deep past. Everything seemed to have found its place. But no species knew that the very things that had once helped it live well in the old world could become a burden when that world began to change. Then the water came, not as one single flood, swallowing everything, but as a new rhythm of the planet. Wet seasons stretched longer. Rain fell more often across many regions. Cracked, dry ground began to soften beneath layers of water. Rivers and lakes expanded. Lowlands turned into marshes. Moisture-loving plants spread into places that had once been too dry. Old paths were cut across by new currents. Nesting grounds could be flooded. Familiar food sources were no longer in the same places, no longer growing according to the same seasons, no longer as easy to find as before. One animal might survive a rainfall. But for an entire species to pass through an age of rain, it had to do something far more difficult. It had to change quickly enough across generations. Out in the sea, the story was not peaceful either. Rivers from Pangaea carried earth-red mud nutrients and decaying organic matter into the ocean. Nearshore waters became murkier. Light beneath the sea weakened. In some places, ancient limestone platforms no longer developed as steadily as before. Some waters became low in oxygen, forcing bottom-dwelling, filter-feeding, shell-forming creatures or organisms dependent on stable environments into difficulty. The ocean seemed vast enough to embrace every disturbance. Yet, in the end, it too had to bear the influence of the rains falling on land. And the sea recorded that disruption not with a roar, but through the absence of creatures that had once existed in ancient layers of rock. But the history of life is rarely only a story of loss. When one group of organisms weakens, nature does not leave behind only a sorrowful emptiness. It also opens new pathways, a source of food not yet fully used, a new riverbank forming, a new kind of forest growing, a new place to live emerging among mudwater and ancient plants. In those empty spaces, smaller, faster, more flexible creatures began to find opportunity. After the rainy age, the old world was no longer as firm as it had once been. And at the edge of the story, in small footprints pressed into soft ground, dinosaurs began to appear more clearly. Dinosaurs did not rise like a victorious army in a single day. They did not step out of the rain with thunderous roars and immediately take over the earth. Their rise was subtler, slower, and therefore more real. They had existed before the event, but after the rainy age they gained new opportunities. Lighter bodies in many early forms, more efficient posture, better movement and flexibility in ways of life may have helped them take advantage of new environments. While some older groups weakened, dinosaurs gradually appeared, more often leaving footprints more frequently, like a small sound growing clearer in the long music of the earth. And if we look even farther, we will see that this reign was not connected only to dinosaurs. It belonged to a period when many important branches of life would later begin to shift direction, expand, or rearrange their roles. Some plant groups developed in wetter environments. Land and marine ecosystems changed. Older communities gave way to new structures. This is why some scientists view the Carnian pluvial episode as one of the turning points leading toward a modern world in an ecological sense, not because humans or modern animals had appeared then, but because many later threads of life began to be drawn into a new pattern. Imagine Earth after the rainy age as a wide room that had endured years of water seeping through its walls, its floor, and its roof. When the water withdrew, the room remained, but it was no longer the same. Some pillars had weakened. Some pathways had been closed. Some open spaces appeared where before they had been hidden. The creatures that survived had to walk through that room and find their place. Some species kept clinging to the old corners until they could no longer do so. Some found new paths. Some small creatures once overlooked were the first to slip through the doors. We often like to tell the history of life through great characters, giant dinosaurs, terrifying predators, falling asteroids, erupting volcanoes. But many true turning points in Earth's story do not happen as one single spectacle. They happen through accumulation. A little carbon in the atmosphere, a longer rainy season, a murkier river, a collapsing lakeshore, a low-oxygen sea, a plant-eating species producing fewer surviving young, a small creature finding a new source of food. Each separate change may seem small, but when repeated long enough, it becomes history. That is what makes the 2 million-year reign both frightening and wondrous. It reminds us that life is not protected by eternal stability. Life always exists on a moving planet. Volcanoes can change the climate. Climate can change the rain. Rain can change the rivers. Rivers can change the sea. And when sea soil, forest, mud, oxygen, food, and breeding places all change, the creatures living within them have no choice except to change with them or disappear. Life does not continue by keeping the same form forever. It continues through trial, error, loss, adaptation, and sometimes by becoming something entirely new. If someone could have stood at the end of that age on a stretch of land, dried after many wet seasons, they might not have realized immediately that they were looking at a turning point in the history of life. Before their eyes, there would only be dry mud, ancient plants, rivers that had begun to shrink, and animals moving through dim sunlight. There would be no sign declaring that a new era was coming. No bright line separating the old world from the new. But in the footprints, in fossil bones, in marine sediments, in ancient pollen, in the rock layers, preserving climate signals that transition had been written down. Earth always remembers in its own way. One of the greatest legacies of this age is the lesson of how fragile success can be. A species may flourish for millions of years. It may occupy vast regions. It may fit its environment beautifully. But if that environment changes deeply enough, old success no longer guarantees the future. Rhynchosaurs were once very common, but then declined. Dicynodonts had endured through many periods, but eventually they too no longer held their old role. Marine communities that had once been stable could be disturbed by mud nutrients, low oxygen, and changes in water chemistry. History does not hate the old. It simply does not stop to wait for them. But another legacy, a gentler one, is the lesson of beginning again. After crisis, life does not vanish completely. It retreats in one place, but opens in another. It loses familiar forms, but searches for new ones. It leaves behind sorrowful spaces, then slowly fills them with other branches of life. From the disorder of the rainy age, new paths began to form. Not immediately, not perfectly, but enough for Earth to continue into the great later chapters of the Mesozoic, where dinosaurs would become figures impossible to ignore. When we think about that reign, we can also feel humbled before time. 2 million years is almost impossible for us to imagine. It is a span far longer than the entire history of humankind many times over. But to Earth, it is only one passage in a story more than 4 billion years long. That long span of rain was enough to alter rivers, change ecosystems, and redirect the fate of many groups of life. And yet it too passed, making way for other ages. Earth never stands still for too long. Even events that seem endless are only one rhythm in the deep breathing of the planet. And perhaps the most beautiful image to end with is not a volcano, nor a low-oxygen sea, nor the species that disappeared. Let us return to a mudflat after rain. The sun is sinking low. Water caught inside small footprints reflects the gray sky. A plant-eating animal passes by, slow and cautious. A small creature runs across the roots of an ancient plant. Farther away, an early dinosaur steps across the soft ground, leaving delicate tracks it does not know will become part of a much larger story. The rain has fallen. The ground has changed. And in that silence, the future begins to move through the mud. Without this long, rainy age, the history of life may have followed another path. Perhaps dinosaurs still would have risen in some other way, or perhaps they would have remained a small group in the shadow of other creatures. Perhaps marine ecosystems would have recovered according to a different rhythm. Perhaps the forests of the Mesozoic would have worn another face. We cannot know for certain all the possibilities that were left behind, but we do know that this rain helped rearrange the board. And when the board changes, the later moves of life change with it. So, the story of Earth reigning for 2 million years is not only a strange fact meant to surprise us, it is a reminder of the power of long-lasting change. A storm can break a tree in a single night, but a new climate can alter an entire forest. A flood can erase footprints in a single day. But millions of years of rain can change the direction of evolution. And when we look back from the present, from a world where birds fly across the sky, crocodiles lie beside rivers, green forests cover the land, and human beings are trying to understand the past, we can see that a very distant part of that story began in the reign of the late Triassic. And here the journey through the great rainy age slowly draws to a close. We have traveled from the fire erupting out of Earth's depths to a sky heavy with water vapor from the muddy rivers of Pangaea to the murky ancient sea, from creatures surviving at the edges to the first dinosaur footprints growing clearer on the land. And after all of it, what remains is not only the question of how animals survived, but the feeling that life has always been more fragile, more resilient, and more mysterious than we imagine. In the quiet darkness of deep time, rain still falls through our imagination. It falls on ancient conifers. It falls on red mud. It falls on rivers flowing out to sea. It falls on the backs of creatures that no longer have names in the world today. And then very slowly, the rain stops. But what it changed continues onward, through dinosaurs, through birds, through forests, through oceans, through countless branches of life, all the way to the planet we are standing on now. And here our journey tonight through Earth's long, rainy age slowly comes to a close. From a hot, dry Triassic world covered in red dust and harsh sunlight, we have watched the sky begin to change color. The clouds grew heavier. Rain fell upon the ancient ground. Rivers expanded. Lakes overflowed their banks. Mud covered the old migration paths. Humid forests spread across places that had once been barren land. And in that landscape, animals were not facing only a storm, but an entirely new age. Some creatures could not continue. They were too deeply tied to the old world, to the old vegetation, to the dry seasons and familiar paths they had always known. But other species found opportunity within the chaos. Smaller, more flexible creatures, better able to endure change, began to move through the empty spaces left behind by the upheaval. And somewhere on the mudflats slowly drying after the rain, the first dinosaur footprints became clearer, as though Earth were quietly writing the next chapter of life. Perhaps the strangest thing about natural history is this crisis does not only end one world, sometimes it also opens the door for another world to begin. After the muddy waters, after the humid forests, after rainy seasons that stretched across millions of years, Earth was no longer the same as before. And from that change, the path toward the age of dinosaurs slowly began to appear. If you enjoy natural history stories told slowly, like this, please subscribe to the channel and follow the fan page so we can continue these bedtime journeys together. And do not forget to leave a comment next time. What age of Earth would you like to hear about the Jurassic period, the Cretaceous period, the ancient oceans, or a creature that vanished from the world long ago. Thank you for listening. I wish you a truly peaceful night.